Lesson 60, direct and inverse variation. Okay, I kind of like this lesson. I think it's a useful lesson. It's also on the SAT, so it's a good thing to learn. When we talk about two things varying directly or indirectly, we can come up with a constant of proportionality. So let's just start with the lesson here. This is a definition. If it says A varies directly as B, or that A is directly proportional to B, we use an equation A equals KB. When the statement says that A varies inversely as B, or that A is inversely proportional to B, then we use A over KB. K is, you see K is in both of these. K is called the constant of proportionality. That's just a fun thing to say. And it's always in the numerator. Now to help you understand that, we're going to do 3 examples and maybe it will come clear to you. Here we go. The number of boys in every classroom of a school varies directly. Okay, right here we can see where it's telling us what equation to use. It says vary directly as the number of girls. So we're going to use this equation right here, A equals KB. But we don't use these same variables. We use variables that describe the situation in our problem. So the boys varies directly as the girls. So we use B for boys, G for girls, and K is our constant of proportionality. In one room there are 8 boys, so we fill in, for the boys we fill in 8. For the girls we fill in 2. And we solve for our constant of proportionality. I just love saying that. K equals 4. Now, knowing our constant proportionality, we can find out how many boys and girls are in each classroom if we know one of or the other. If we know how many boys, we can figure out how many girls are in the classroom. If we know how many girls, we can find out how many boys are in the classroom. So the first thing you do in these problems is you find K. It says in one room there are 8 boys and 2 girls. Okay, if there are 5 girls in another room, how many boys are in the room? So this is a 2-part problem. The first part is you're going to find your K. The second part of the problem is we use our K and the other variable that they gave us to find the variable that we're looking for. So here we go. If there are 5 girls in another room, so we're going to start with this same thing, B equals KG. This time they're telling us that there's 5 girls. So for the G, we're going to put the 5, and we know our constant of proportionality, our K, is 4. So we can find out that the number of boys is equal to 20. And that's how you do it. First step, you fill in the 2 variables and find K. In the second step, you use K in one of the variables to find the other variable. Let's try another one. These are a little bit fun. The number of revolutions per minute, RPM, varies inversely. Okay, this time we're using the other equation. When you see inversely, it means we're going to use the equation A equals K over B. That's our inversely, or inversely, varies inversely or inversely proportional. The number of revolutions per minute varies inversely as the number of teeth. Okay, so let's get our right variables in here. A is our RPMs, varies inversely as the number of teeth in the gear, so we'll just call that N. Now once we have this set up with the right variables, we just substitute in. If 40 teeth result in 100 RPM, okay, they're trying to trick us here. So 100 RPM, so we put 100 here, and we have 40 teeth. I should have called that T, that would have been more fun. So we get K equals 4,000. constant of proportionality. Part 1. Part 2, we're going to use this constant of proportionality and another piece of information to get the third piece of information that we don't know. So here we go. We're going to use the same thing. RPM equals K over N. If 40 teeth result in 100 RPM, what would the RPM be? So that's what we don't know if it had 30 teeth. So RPM, our constant of proportionality we get over here, is 4,000 divided by our number of teeth, which is 30. So we can get the RPM equals 4,000 divided by 30, which gives us 133 1/3 RPMs. So hopefully you're finding this pretty easy. Eventually we're going to combine inversely and directly all into one problem. Okay, last problem. The number of clowns was directly proportional to the number of performers. So here we go. Clowns directly proportional to the number of performers. Why don't you stop the video and see if you can do it, and then turn it back on and see if you got it right. Okay, let's see if you got it right. If there were 40 clowns when there were 20,000 performers, we can figure out our constant proportionality by dividing both sides by 20,000, and we're going to get K equals, Jake just cleaned my family room for me, so it's a nice thing for him to do. So we're going to get, for our constant of proportionality, 40 divided by 20,000, and we can reduce that, and it's going to be 1/500. So K equals 40 divided by 20,000, and we get 1/500 if we reduce that. So that's our constant proportionality, and that's part 1. Part 2, we use the same equation. I guess I don't need to write that down again. So it says, if 40 clowns when there were 20,000 performers, how many clowns would there be if there were 12,000 performers? So clowns equals 1/500. This time we have 12,000 performers. How many clowns would there be? So we can multiply those together, and we're going to get 24 clowns. This is actually a really handy thing to know, to be able to do. You'll see this later when we do more algebra problems, how practical it is. So that's it for lesson 60.